For this video, let's talk about the outline of solution or solving a homogeneous equation or a differential equation with homogeneous coefficients. We know that for any differential equation in this manner, m of xy dx plus n of xy dy equal to 0. Okay, if we could guarantee, okay, just a short review, if we can guarantee that our f of xy and n of xy are both homogeneous functions, let's say m of tx ty is equal to t to the power of alpha of your m of xy. Similarly, for your n of tx and ty, which whatever will be the form of x and y in that, t alpha n of xy, both of them are homogeneous functions and they share the same alpha, same degree. Then we can say that again, this is a homogeneous differential equation. If this will be guaranteed, then let's try to talk about the steps of solving. Okay, steps of solving the homogeneous equation. Now, the first thing here is, or the only consideration in solving homogeneous equation just like this, is actually by the process of substitution. Okay, by substitution, we can actually pick another variable that would describe a combination of x and y or their forms, and later on we could come up with a separable differential equation. So we're going to reduce this to a separable differential equation, and we're just going to use the integral of both sides of the equation to solve for our equation. So how do we do that? The first thing here is this. The first consideration that we could do, or the first, it might be the first step, let's consider this a first step, is actually giving a certain representation for, let's say, y is equal to vx. Okay, so if we can actually write y in terms of vx, okay, so we can actually substitute all y's in our equation here in terms of v and x. So what will appear now in our equation would be v and x. And if it could result into a separable differential equation, and that's good. The second idea, let me just use here double I, is the other way around. Let's have x is equal to vy. So we are going to express y in terms of x and v, or express x in terms of v and y in our entire equation. Okay, so you can only choose one. Okay, it's up to you. Now, the next step here, if I may, is when you will be deciding I or double I, you will also have different results now. Because if we're going to use our I, the derivative of that, the derivative of y, is equal to the derivative of the product of this. And we know that the derivative of product, okay, it's actually a sum of these combinations. You have the first term, derivative of the second term, and plus the derivative of, let's have the second term, and the derivative of the first term, right? Okay, so once you do that, you also be substituting this to all dy's that you can find here, specifically for this portion here, okay? But if you're going to choose the second, where you express x in terms of vy, your derivative of x would be v dy plus y dv, okay? This would be substituted to our dx here. This is a guarantee that when you're going to choose any of these two connected to our step 1, again, i's will be patterned to i's, double i's to double i's, okay? So we're going to pattern that. The third one is, of course, we're going to use here solve by separation of variables. Okay? Separation of variables. Of course, the process of separation of variables is also discussed in one of the videos. The first thing is, before you use the integration of both sides, you need to make sure that all dv's or dy's or dx's are actually paired to specific variables for it to be integrated, because you cannot just simply say, for example, you have here x and then you will have dv here. You can integrate that. It should be x and dx, right? So you need to consider that as well. Now, there is also another thing you need to talk about here, because take note, the original variables are actually x and then y. If you're going to use by substitution, you may have here vy or vx, right? That would mean there exists v now on our final form, okay? In our final form. Make sure that when you have v in our final form, always return to these expressions here so that your v would be expressed in terms of y and x or a combination. So for our first output here, or first consideration, if you're going to choose I, your v is actually y over x, right? For the second, your v is x minus y. My point here is, as soon as you're done solving using separation by variables, your v's would be changed into these components here on their respective forms, so that you will just return to the intended output containing the variables x and y, because basically your original function contains x and y. We will have examples on solving homogeneous equations later, so please try to view them properly and review them from time to time so that you were able to compare this process in solving other forms of differential equations, specifically for first order differential equation. Thank you very much for watching.